So, welcome everybody to this week's problem set, which will be the last problem set of this course. And I will basically cover a mock exam for this week. So, this is, a mock exam which covers basically the different topics of this lecture. And it consists of three exercises. Two of them are calculation exercises, and one of them is more theory question. Yeah, and so let's go through it. So in question number one, we have the following. Consider an economy with two consumption goods, X1 and X2. Denote labor by L, and L is then simply between 0 and 1. Consumers have identical utility functions given by the minimum of X1 and 1 minus L, so the minimum of good 1 and leisure plus 2 times X2. X1 can be seen as kind of leisure goods, leisure suits, sorry. And yeah, X1 then simply denotes the number of leisure suits. As you can see, the consumers cannot enjoy leisure without the leisure suits. And here you can see that X1 is a perfect complement to leisure 1 minus L. The good X2 represents all other consumption goods that you can think of. Assume competitive production so that the producer price of J is Pj and it's equal to W, and we normalize W to 1. Therefore, the price of good J is equal to 1. We assume that consumers have no non-labor income, so they basically have to work to generate income. There is no capital income. The government, which objective is to maximize aggregate welfare in this economy, needs capital T units of tax revenue, and we assume that it needs less than 1 unit of tax revenue. To raise revenue, the government imposes linear taxes on the goods. So we have commodity goods taxes here. These are T1, T2. And by Q1 and Q2, we denote the post-tax price vector. In sub-exercise number 1, we are asked the following. Find the consumer's demand for goods X1, X2, and the labor supply L. And there is a small hint given here. Assume that if indifferent between supplying more or less labor, the consumers will supply more labor. Remember that neither demand nor labor supply can be negative. Show that labor supply and therefore consumption depends on the sign of the term, which you find down here. So 2 times 1 plus Q1 divided by Q2 minus 1. Okay, good. So let me go to a new page. So this is question number 1. So yeah, I will give you kind of more input than what you would typically have to write in the exam. So I will not simply give you the solutions here, but I will also give you some explanations. Yeah, so some of them are not needed when you're going to answer the questions in the exam. Good. So the first thing that we need to notice is that good 1 and good and leisure are perfect complements. Okay, so good 1 and leisure are perfect complements. Okay, basically this means that the consumer wants to consume good 1 and leisure in a particular ratio. So basically in a 1-to-1 ratio, any deviation does not give you more utility. Yeah. So if you, for instance, consume 0.5 units of good 1, then if you have a leisure of 0.7 or even 1, you do not benefit more, like you do not derive more utility from this. It's always the minimum which matters. So basically, this means that the optimal ratio optimal ratio is always such that x1 is simply equal to 1 minus L. So the amount of leisure suits is equal to the amount of leisure that you're enjoying. So if you decide to choose a strictly positive, or if you want to consume a strictly positive amount of good one and leisure, it needs to be in this ratio. Otherwise, it cannot be optimal because then you can reduce consumption of the good. Hence, you save money without decreasing your utility. Now, what we can do is we can think of the bundle consisting of x1 and 1 minus L. So you can think of this as like of this vector which consists of the amount of good one and leisure as a bundle. A bundle which has a price of 1 plus Q1. Okay, so obviously Q1 because that's the post-tax price of good one, and the one is coming from the fact that the opportunity costs of leisure, so basically the price of leisure is the wage that you could get if you would not enjoy leisure. And since this is one, that's basically the price of leisure. Good. So now that we basically know that good one and leisure are basically a bundle, we can go to the next good, which is good two. And what we there see is that the bundle is a perfect substitute to good two. Okay, so the bundle x1 1 minus L is a perfect substitute to good two. So basically this means that we do not need to necessarily consume a strictly positive amount of on both the bundle and the and good two because of the linearity that we have here with respect to the utility function. Yeah, so basically the bundle is additively here, so is good two. Therefore, if we consume 0 units of one of the good, it does not affect the utility that we derive from the bundle, basically. Yeah, so the amount of in a direct sense. So the amount of good two that I'm consuming does not affect the utility, so directly the utility that I'm deriving from consuming the bundle and vice versa. So they're basically perfect substitutes. So what we need to find out now is depending on the prices that the consumer has to pay, will he either consume the bundle or good two? So basically this means that consumer will either consume bundle or good two. Okay, so basically this gives us two possibilities. So we have two possibilities in total. Oh, this is one too much. Possibilities. Oh no, it was correct. Yeah, it's really with so many eyes. So we have two possibilities. Um, The first one is that we consume a strictly positive amount of the bundle. So the first one is x1 equal to 1 minus L, and x2 is equal to 0. Or the second opportunity would be x1 is equal to 0, x sorry, L is equal to 1. Yes, I'm not enjoying any leisure at all. And x2 is equal to L divided by, oh, sorry, the L here should be like this. Let me just check up here. I wrote the L like this. So just to be consistent, let me correct this so that this be also L like this. So it's L divided by x2. And since L is 1, it's then 1 divided by x2. Okay, so given this utility function, those are the two possibilities that we have. Yeah. So the next thing that we need to derive are the marginal utilities for the both possibilities. So for the bundle and for good 2. So the marginal utilities are things which we need to compare whether we will consume the bundle or whether we will consume good 2. So marginal utilities, the bundle gives us a marginal utility of 1. Yes, so if we increase either the amount of the consumption of good 1 or leisure, while keeping in mind that obviously they have to be the same, the marginal utility is simply 1, and good 2 is 2. Yeah, so if you take the derivative of the utility function with respect to good 2, you end up with 2. Okay, but this obviously doesn't mean that only because the marginal utility of good 2 is higher, we will necessarily only consume good 2, because the prices matter. Okay, so the prices matter if the price of, so what you have here is that the marginal utility of good 2 is 2 times, so it's double the marginal utility of the bundle. But if the price for good 2 would be, for instance, 3 times as high as the bundle, then you wouldn't consume good 2 anymore. Yeah, because you can afford more of the bundle, and it gives you a better marginal utility to price ratio than good 2. Okay, so what we can do now is we can derive kind of a condition which determines whether we will consume good 2 or not. Okay, so this is basically the answer to question number A when we're doing it. So good 2 will be consumed if and only if the following holds. If the marginal utility of good 2 divided by the post-tax price of good 2, which is Q2, is weakly larger than the price of the marginal utility of the bundle, which is 1, divided by the price of the bundle, which is 1 plus Q1. If you rearrange this, what you get is 2 times 1 plus Q1 divided by Q2 minus 1 is supposed to be weakly larger than 0. Yeah, and since we assumed that if the consumer is indifferent, he will supply labor, basically we have the weak inequality here. Yeah, so if this holds, then only good 2 will be consumed and the labor supply will be 1. So this means that L star, so the labor supply in equilibrium, is equal to 1. X1 star is equal to 0, and X2 star is equal to L divided by Q2, so it's 1 So L star divided by Q2, so it's 1 divided by Q2. Okay, so this is kind of the solution if this condition here is fulfilled. Then the bundle will be consumed. The bundle will be consumed if then the condition doesn't hold, so it's 2 times 1 plus Q1 divided by Q2 minus 1 being strictly smaller than 0. So in this situation, what will happen is that x2 star is equal to 0. So the consumer will not consume anything from good 2, and he will consume x1 and x1 leisure in a way that it holds that x1 is equal to 1 minus L. Okay, so basically x1 is equal to 1 minus L. And now if we plug this into the budget constraint that we have, so the budget constraint of this optimization problem, I think I didn't mention it before, but we can write it down really quick here. So the budget constraint of this problem is given by the following. Just 1 second. So the budget constraint is Q1 times X1 plus Q2 times X2 is equal to L. Okay, so this is the budget constraint. My expenses on good 1 plus my expenses on good 2 must be equal to the labor that I supply times the price or the wage of labor, which is normalized to 1. Yeah, so this is why I'm not writing it down here. So this is the budget constraint, and this will be needed. So if you plug in this relation, so plug in to the budget constraint, and if you do this and solve for, you can either plug in x1 or L, it doesn't really matter. But let's say we plug in for x1, then we have so what you need to plug in is x2 star equal to 0 and x1 equal to 1 minus L. Then what you will have is an equality with only L as a variable. And then what you get gives you L star being equal to Q1 divided by 1 plus Q1. Okay, so then if you plug this back into this relation here, what you get is x1 star is equal to 1 divided by 1 plus Q1. Okay, so this is then the demand for leisure or labor, and also leisure, and good 1 in equilibrium if you do not consume any amount of good 2. Good, let us wrap this up here. So let's collect all the information that we have. So the demand and labor supply are given by the following. So it's x1 star equal to 0, L star equal to 1, and x2 star equal to 1 divided by Q2 if 2 times 1 plus Q1 divided by Q2 is weakly larger than 0. So here we do not consume anything from good 1 and we do not consume any leisure. So we're simply working and consuming good 2. Then we have the second case, so x1 star being equal to 1 divided by 1 plus Q1, L star being equal to Q1 divided by 1 plus Q1, and x2 star being equal to 0. And this holds if 2 times 1 plus Q1 divided by Q2 is strictly smaller than 0. And this finishes sub-exercise A. and brings us to sub exercise B. And here we are asked to find the consumer's indirect utility function. So here we simply plug in for each of the two cases the optimal demand for the goods and the optimal labor supply into the utility function, and then we get the indirect utility function for the two cases. Okay, so let's go back here. Okay, so if we plug in the values, so what we have is the indirect utility function, which then actually only depends on Q1 and Q2. So I think in the solution that I uploaded on Moodle, I put the optimal values of the of consumption and labor supply here, but basically the indirect utility function is a function of the exogenous parameters. So yeah, just don't get confused there because x1 star, x2 star, and L star are actually exogenous or are also functions of exogenous parameters. So here I'll just write Q1 and Q2, and it's equal to 2 divided by Q2 if 2 times 1 plus Q1 divided by Q2 minus 1 is weakly larger than 0. And it's 1 divided by 1, 1 plus Q1, if 2 times 1 plus Q1 divided by 2 minus 1 is strictly larger than 0, strictly smaller than 0. Okay, so this is the indirect utility function. So you simply plug in for each of the cases the values of the endogenous variables in equilibrium. Good. So then let's proceed to C. C is an optimization problem for the government. So we're asked to find the optimal commodity taxes as a function of the revenue, the tax revenue that the government needs to raise. Good. So let's go back and write down the optimization problem. So the objective of the government is the following. So it is maximizing over commodity taxes Q1 and Q2. And it's maximizing the indirect utility function of the consumer. Okay, so depending on Q1 and Q2, such that there is a kind of budget balancing situation. Yes, so such that the tax revenue that the government is raising from good one, so this would refer to Q1 minus 1 times the amount of good one, which is consumed, of course, in optimum, plus the tax which the government is raising from good two. Yeah, so we the subtract one here because then we end up with the actual tax, not the post-tax price for the consumer, because the government is not receiving the post-tax price, but it's only receiving the tax. This will be multiplied with x2 star, and this is supposed to be equal to capital T. Okay, so basically this is now the optimization problem or the objective of the government. Now, what the government can do is it, depending on Q1 and Q2, it can have like, or can impact the consumer in a way that he will either supply labor or he will either not supply labor at all. Yeah. So basically, those are the two options that we have. So then now if the government is choosing, so we go to the cases now. So if the government chooses Q1 star being larger than Q2 star minus 1 divided by 2, then obviously it will hold that 2 times 1 plus Q1 divided by Q2 minus 1 is weakly larger than 0. Okay. So if the government is choosing the taxes in a way that this holds, then this year is fulfilled. So if Q1 is relatively large relative to Q2, it means that the inequality here is fulfilled, and therefore the consumer will only consume good two. So if the taxes on good one are too high, then the consumer will only consume good two. Okay, so let's go just a little bit back here. Um, so if this holds, then the consumer will only consume good two. So if the government is only if the consumer is only consuming good two, the budget constraint of the government will look the following way. So then the budget constraint will be like this. So it's then Q1 star minus 1 times 0 plus Q2 star minus 1 times 1 divided by Q2 star. Yeah. So this is then the demand of the consumer for good 2 if he is only consuming good 2. This is supposed to be equal to capital T. And if you solve this, you get, so if you solve this and you consider that Q2 star is equal to, it's equal to 1 plus T2 star, what you get is T2 star being equal to T, so capital T divided by 1 minus T. And given this value, the indirect utility function, so the indirect utility is the following. So V star of capital T now, so it only depends now on the revenue that the government wants to raise. It's equal to 1 divided by, sorry, there is a mistake here. It is 2 divided by Q2 star. Therefore, it is 2 times 1 minus capital T. Yeah, so simply plug in and simplify a little bit. Good. Now, given this expression here, we finished the case where the government is choosing the taxes such that there will be only a consumption of good two. What we obviously need to consider is the other case. So now we go to the case where the government is choosing taxes such that the following holds. So if Q1 star is strictly smaller than Q2 star minus 1 divided by 2, then the consumer will not consume any unit of good 2, but he will only consume leisure and good 1. Then the budget constraint, so here consumer only consumes good 1 and leisure. As a consequence, the budget constraint of the government would look in the following way. So it's then Q1 star minus 1 times 1 plus 1 plus Q1 star. So this is the demand for leisure or the demand for good 1. Yeah, since they're equal in the equilibrium due to complementarity. This is basically the same here. To this we add then Q2 star minus 1 times 0 because there is no consumption of good 2. Hence, the government is not raising any revenue due to the consumption of good 2. This is supposed to be equal to capital T. And if you solve this for Q1, and then if you consider that Q1 star is equal to 1 plus T1 star, you get at the end T1 star being equal to 2 times T divided by 1 minus T. And now the indirect utility function is the following. It is then V star of capital T being equal to 1 minus T, 1 minus capital T divided by 2. Okay, so this is the indirect utility if the bundle is consumed and good 2 is not consumed. And this here is the indirect utility if only good 2 is consumed. Okay, this brings us to the final sub-exercise. So this would be D. And here the question is, show that optimal commodity taxes satisfy 2 times 1 plus Q1 divided by Q2 minus 1 being weakly larger than 0. So basically we're asked to show that the government will choose the taxes in a way that there is no consumption of good 1. And for this, we can simply compare the indirect utility functions. So compare indirect utilities of the two cases. Since the government wants to maximize the welfare, basically the indirect utility of the consumer, it will choose the commodity taxes in a way that the consumer chooses either the bundle or the good 2, and it will choose commodity taxes such that the consumer makes a decision such that the indirect utility function is maximized. So what we then compare is simply the indirect utilities in the two cases. And as you can see, 2 times 1 minus t, which is the indirect utility if only good um, 2 is consumed, is strictly larger than 1 minus t divided by 2 for all t. So for all capital T in I think it was the restriction which we had to consider was the revenue being strictly smaller than 1. So for all values that we have here, this is fulfilled. So since this holds, so the indirect utility of the consumer, if he only consumes good 2, is strictly larger than his indirect utility if he consumes leisure in good 1. The government will only always choose commodity taxes in a way that we the consumer is only choosing good 2. So therefore, optimal commodity taxes fulfill 2 times 1 plus Q1 star divided by Q2 star minus 1 being larger than 0. Okay, so the reason for this is simply that the indirect utility function of the consumer is higher when he is consuming good 2 only rather than consuming the bundle. And yes, this finishes this exercise.